Alright, in this video we're going to look at how to find a partial differential equation given its general solution. So what we're going to be doing in this video is the reverse of what we did in an earlier video, where we used the method of characteristics to find the solution of a PDE like this one, for instance. So if you've got xux minus y uy here equal to y squared minus x squared, where u is a function of x and y. Then we showed that the general solution of this PDE is given by a function of xy and x squared plus y squared plus 2u equal to 0, where f is an arbitrary function. This solution, we can rewrite it as follows. If we make u the subject of the formula, then we can write this as u equal to f of xy, where this f now is going to be different from that f. Then this is going to be minus x squared plus y squared all over 2. Now, so what we want to do in this video is to show you how to go from this solution back to that PDE there. Alright, so just two things to note before we look through the examples. The first one is that the order of the PDE is going to always correspond to the number of number of arbitrary functions in your general solution. So for instance, in this case there is only one arbitrary function, so that's why this PDE is of degree 1. And in particular for this video, we're going to focus on general solutions with only one arbitrary function. Then the other thing is, so we're going to find the PDE by just differentiating and then eliminating the arbitrary function. So we're going to differentiate and eliminate the arbitrary function. So in this case it's going to be 1, but it can be many functions. So that's basically what we are going to want to do in this video. So let's write out some examples. Alright, so here we are given that u is a function of xy and f is an arbitrary function. So we want to find the PDE satisfied by this general solution. For instance, we're going to do A and B, then we're going to give you C and D to try on your own before we show you our solution. So let's have a go at the first one. So A, we have got u equal to x squared minus y plus a function of y squared over x. So what we're going to do here is we're going to differentiate this thing first with respect to x, So on the left hand side we're going to have ux, then derivative of x squared is going to be 2x. Derivative of y is going to be 0 because this is the partial derivative of everything with respect to x. Then the derivative of this thing, we're going to have to use the chain rule. We've got x in the denominator, so that is going to give us minus y squared over x squared, and then times f prime. So from here we can make f prime the subject of the formula. It is going to be equal to x squared over y squared times 2x minus ux. So let's call this equation number 1. Then we're going to go back to this thing and now differentiate it with respect to y. The left hand side we're going to have uy, then derivative of this with respect to y is 0, derivative of this one is minus 1, then derivative of this function here with respect to y is just 2y over x, and then times f prime. And then this time, if we make f prime the subject of the formula, this is going to be x over 2y times uy plus 1. Call this one equation 2. Then between equation 1 and equation 2 we can eliminate f prime. Since we have got f prime here and f prime there, then these two must be equal. So we're going to write x squared over y squared 2x minus ux is equal to x over 2y uy plus 1. And then if we clear out the fractions, so this thing is going to give us 2x into 2x minus ux. And then on the right hand side, which is going to have y into uy plus 1. So basically what we will have done here, you can see that the x is a common factor and y is a common factor there. So if you just multiply everything by y squared, then divide, actually if you multiply by 2y squared, then you divide by x, then this is what we're going to get. And then if we expand these brackets, this is what we're going to get for x squared minus y. Then we're going to bring all the derivatives of u to the right hand side, and so this is going to be our PDE, which is satisfied by this general solution here. Right. So next we're going to look at the second example. So in the second example we have got u equal to x squared y plus f of x u squared over y. Okay, so it's going to be the same procedure. We're going to differentiate this thing once with respect to x. So if we do that, the left hand side is going to be ux, and then derivative of the first term is going to be 2xy. Then here we're going to have to use the product rule because there is x here, and yet u is also a function of x. So if we use the product rule, then this is going to be plus u squared over y. If we just differentiate the x, then we are now going to keep the x fixed and differentiate the u, so it's going to be 2u ux over y, and then this is all going to be times f prime. Now again, we can make f prime the subject of the formula here. So if we take this to the left hand side and then divide by that, if we do that, we're going to get y into ux minus 2xy, and then this is all going to be divided by u squared plus 2x ux. So let's call this one equation number 1 this time. And then we're now going to differentiate this thing with respect to y. So as a function of y there, there's y there and there's y there, so it means this time we're going to have to use the product rule or the quotient rule, whichever one we prefer. So on the left hand side, going to have uy. The first term here is just going to give us x squared. Then if we start by differentiating the u squared, is going to be 2u uy this time divided by y, and then we're going to have x u squared over y squared when we differentiate the y using the chain rule. And then again, if we make f prime the subject of the formula this time, we're going to get f prime is y squared into uy minus x squared. Just take this term to the left hand side, and then this is all going to be divided by x into 2y uy minus u squared. Okay. Notice that the x common factor of x has been factored out here, so this one I'm going to call equation number 2. And then so if we equate these two, so we're going to have, so the first one is y into ux minus 2xy all divided by u squared plus 2 ux. And then the second one is the one we have just above here, so uy minus x squared all divided by x into 2y uy minus u squared. Okay, then we're going to cross multiply here and collect terms, so it's just going to be a bit of algebra. So maybe let's take you through the first few steps. So basically, if we take this one to the right hand side here, and now so notice here that y is common, so we're going to divide by y at the same time. So we're going to have x into 2y uy minus u squared ux minus 2xy. That's going to be our left hand side, and then on the right hand side we're now going to have y into uy minus x squared. So that's this term here, then we'll multiply by this term. So and the term is 2 x ux plus u squared. So that is going to be our right hand side. And then if we multiply here, so on the left hand side, this is what we are going to get when we multiply the first terms. So that means this term and this term, we are going to have 2xy u ux uy minus, then we are going to multiply these two terms here. So it's going to be u squared u x times x. Okay, and then we are going to multiply this first term with the last term. So that's going to give us minus 4x squared y squared u uy, and then lastly we are going to have 2x squared y u squared. So that's going to be the terms on the left hand side. Then on the right hand side, we're going to have 2xy u ux uy, multiply this term and this term, and then we're going to have plus y u squared u y. We're now multiplying the first and the second. Then we're going to have minus 2x cubed y u ux. So we are multiplying the second term and the first term. And then lastly, we're going to have minus x squared y u squared. All right. Now, then upon close inspection of this, I'm going to notice that this term is exactly the same as the term. So those two terms cancel out. And then you're going to notice that this term is a like term to this one here. So what that means is that if we collect terms and rearrange, then our PDE is going to look as follows. So we're going to have x into u minus 2x squared y times ux plus y into u plus 4x squared y uy. And then on the right hand side, we're going to have 3x squared y times u squared. Okay, so that's just these terms here. Okay, so that is going to be our PDE then. All right, so this time we are now going to give you, so if you just want to take a few minutes and have a go at these two here, so what you can do is you can pause the video, then have a go at these two, and then when you press play, then you will find our solution, which you can then compare with your own. All right, so we imagine that you've had a go at these two here. We're now going to scroll down to our solutions with which you can then compare. So for C, if we start by differentiating with respect to x, we're going to have to use a product rule here, because there's x here and x there. Differentiating this one gives us this term, and then if we keep this term fixed, differentiate this, we're going to have f prime times the derivative of the argument is 1 over x. And then what we're going to do is from here we can make f the subject of the formula. So it's going to be uy over x squared. So then we're going to take this and plug it in there. So that's what we have here. And then after that we can make f prime the subject of the formula, which we have here in equation number 1. Then differentiate this thing now with respect to y. Again, gonna have to use the product rule because we've got y here and y there. So if we differentiate the first one, and then when we differentiate this one, is going to give us 2y. We multiply into that, so that is going to be just 2x squared. Then we plug in uy over x squared in place of f and make f prime the subject of the formula. So then equating equation 1 and 2, that eliminates f here, and then just after a bit of algebraic manipulations here, then we have got our PDE, which is 2xy squared ux minus yuy, and then on the right hand side got 1 plus 4y squared times u. Right, in this case the argument of f involves u, but the procedure is pretty much similar. So if you differentiate with respect to x, this is going to give us 2xy. This one, there is no x here, but there is x there, so it's just going to be u of x times f prime. Then we can make f prime subject of the formula there. Then it differentiate this thing with respect to y. Now there's y here, y there, y there. So this is going to be x squared. Then derivative of this is 2y. Derivative of this is going to be uy times f prime. Then again make f prime subject of the formula. Then so that is going to be equation number 2. Then equating these two is going to give us our PDE after just some algebraic manipulations. Okay, thank you for watching this video. If you found it useful, you can subscribe to our channel so that you can get all the new videos that we're going to be posting on partial differential equations. Thank you.